the base unit of time in the international system of units, and by extension most of the Western world, is the second, defined as about 9,000 million periods of radiation of the caesium atom. Historically, units of time were defined by the movements of astronomical objects, sun-based. The year was the time for the Earth to rotate around the Sun. Year-based units include the Olympiad, the lustrum, the indiction, the decade, the century, and the millennium. Moon-based. The month was based on the Moon's orbital period around the Earth. Earth-based. The time it took for the Earth to rotate on its own axis, as observed on a sundial. Units originally derived from this base include the week at 7 days, and the fortnight at 14 days. Subdivisions of the day include the hour, which was further subdivided into seconds and minutes. Celestial sphere-based. As in sidereal time, where the apparent movement of the stars and constellations across the sky is used to calculate the length of a year. These units do not have a consistent relationship with each other and require intercalation. For example, the year cannot be divided into 12 28-day months, since 12 times 28 is 336, while shorter 365. The lunar month is not 28 days but 28.3 days. The year, defined in the Gregorian calendar as 365.25 days, has to be adjusted with leap days and leap seconds. Consequently, these units are now all defined as multiples of seconds. Units of time based on orders of magnitude of the second include the nanosecond and the millisecond. Historical. The natural units for timekeeping used by most historical societies are the day, the solar year and the lunation. Such calendars include the Sumerian, Egyptian, Chinese, Babylonian, Ancient Athenian, Hindu, Islamic, Icelandic, and Mayan, and French Republican calendars. The modern calendar has its origins in the Roman calendar, which evolved into the Julian calendar, and then the Gregorian. Scientific time units. The jiffy is the amount of time light takes to travel 1 Fermi in a vacuum. Planck time is the time light takes to travel 1 Planck length. Theoretically, this is the smallest time measurement that will ever be possible. Smaller time units have no use in physics as we understand it today. The 2 is a unit of time defined as 1024 microseconds for use in engineering. The Svedberg is a time unit used for sedimentation rates. It is defined as 10⁻13 seconds. The galactic year, based on the rotation of the galaxy, and usually measured in million years. The geological timescale relates stratigraphy to time. The deep time of Earth's past is divided into units according to events which took place in each period. For example, the boundary between the Cretaceous period and the Paleogene period is defined by the Cretaceous-Paleogene extinction event. The largest unit is the superaeon, composed of eons. Eons are divided into eras, which are in turn divided into periods, epochs and ages. It is not a true mathematical unit, as all ages, epochs, periods, eras or eons don't have the same length. Instead, their length is determined by the geological and historical events that define them individually. The light year is not a unit of time, but a unit of length, about 9 trillion kilometers.